Hello, friend. My name is Derek Carter, and in this video, we're going to continue looking at generative AI, generative deep learning. We're going to turn our attention to generating images. All right, so we'll look at DeepDream, which is an older precursor to doing image generation. But so if you're familiar with the more modern versions, often you can give a textual description, and they'll generate like an image for you. Right, so in those models, basically they're using the labels for images to first take textual input and use that as a sequence to then generate images. So we'll look at DeepDream here, which is over 10 years old, but it's a generative method that is similar to when we looked at exploring the convolutional layer filters to try and better understand how they worked. So one of the methods that we did was we defined a loss function, and we would start with a random image and then optimize it so it would maximally activate one filter. Okay, so that's really what DeepDream is doing at its heart, with a few modifications. Okay, and that similar technique is at the back end for other generative image methods that you're probably familiar with that are out there right now. Okay, so anyway, with that, let's go ahead and get started and look at the DeepDream for generating images. Okay, so like I said, we'll look at DeepDream here. So it's already 10 years old, and DeepDream was one of the first kind of image generation examples. So it's an artistic image modification technique that is using the representations learned by convolutional layers of a deep network. All right, so basically the same technique that we looked at in a previous video when we were talking about convolutional neural networks. All right, so it's almost identical to the filter visualization technique that we looked at, which consisted of running a convolutional network in reverse and doing gradient ascent on the input in order to maximize the activation of a specific filter in the upper layer of the convnet. Okay, and in this example, we're going to be using a pre-trained convolutional network like we did on those previous examples that was trained on ImageNet. So the difference is, it's the same idea. There's a few simple differences. So instead of maximizing a single filter in a single layer, we're going to try and maximize the activation of all the filters across multiple layers. Okay, so and of course you can pick which layers you want and do other parameters to get other effects for this sort of image generation technique. Also, we're not really interested in trying to figure out what the filter or filters per layer are doing. We want to generate unique images in this case. So we'll actually start with a pre-existing image and do this generation on it. Okay, so some of the generative image systems that you're familiar with, like I mentioned in the introduction, you start with a textual description. Okay, so in this case, we're going to start with an actual image, and we will basically be augmenting it to have it kind of generate dreamlike features onto our existing image. Okay, so so by selecting different convolutional layers, the input images are going to be processed at different scales. So we'll call that octaves here, which improves the quality of the visualization. All right, with that, let's go ahead and do a quick example then of how kind of DeepDream works in practice. Okay, so let's show probably a relatively quick example of doing the sort of image dreaming using DeepDream. So like we said in the introduction, we're actually going to be generating from an existing base image. Okay, so our example uses this image here of some coastline data to generate a dream from. And we also mentioned we do need a convolutional network that's already been trained. So typically with these, you'll want something trained on a really big data set of images, like the ImageNet data set. Right, so here we'll use an inception model. We've run across some examples of using inception models before in this class here. So, this has lots of convolution layers with batch normalization in between and other things going on this inception model. So, what we want, we're going to pick a couple of layers and we're going to define a loss function that we want to maximize. So we're really doing maximization here again. So in this case, we'll use these 4 layers. You can pick different ones, so the ones you pick will have big effects on the kind of generation dreams that you do on your images. These other parameters here on the layer settings are kind of like a regularization or a weighting parameter. So we're going to give more importance to, the numbers here are kind of low to high. So these are going to be more low-level features, and these will be more high-level features that were learned by the hierarchy of our convolutional network here. And like we did before, we used the power of Keras to actually create a feature extractor. So by feeding these in, we can actually get the outputs just of these layers, the output activations, which is what we want in order to define our loss function here. So next we'll compute our loss function. So maybe I won't go over this in too much detail. We're really just using the L2 norm, which means that we're just taking the square, like the average square of the activation. So we pull out the activations of the layers that we defined before. So you can get edge effects. So we just kind of remove the borders around this to kind of reduce or remove those as much as we can. And we multiply, again, this is just that coefficient. So, again, since we're trying to maximize, a bigger number means we're going to give more weight where we have a bigger coefficient to our loss function, right? So if we're trying to maximize whatever this loss function outputs, those things with higher numbers will end up getting more emphasis than the ones with lower numbers for the layers that we define in our loss function. And then for DeepDream, we're going to be using a hand-built gradient ascent optimization loop here, right? So again, this is pretty much the same as the previous example where we did this for a single feature in a convolutional network layer. So for a single step, we want to use that loss function to compute the loss inside of a gradient tape so that we can get the gradients with respect to the image, right? So the gradients of our loss with respect to the image. From that, we do a little normalization on this, but from that allows us to calculate an update for the image that will actually maximize our loss function. Right, so we're not taking the negative of this, we're taking the positive of that because we're doing a maximization here along with some learning rate. So we take small steps along the gradients that are calculated here. So again, then the learning rate is another parameter that you might want to tweak in order to get better or worse effects for this kind of deep dream here. And then our optimization loop is really just doing that multiple times. So we do some number of iterations of this gradient ascent step. Although here we're checking that if we reach some maximum, we stop right away on the gradient ascent. And so before we can do this, just a couple other details. Like I already mentioned, this works best if we do it at some different scales. So we'll do it kind of at one image size, and then we'll rescale the image to be bigger and do it again. So we'll do that 3 times. That's what is referred to as octaves here. So we're actually going to be running this gradient ascent, so our optimization 3 times, multiple times here for 30 iterations each. We do have to do some pre-processing of the image, and then once we're done, if we want to see the final result, we kind of have to do the reverse deprocessing. So let's go ahead and run it. So basically this will run the loop over those octaves and perform the kind of dreaming network. So let's go ahead and let that run. Okay, and that shouldn't take too long. like I said, it's going to run it 3 successive times, calling the gradient descent loop for 30 iterations each. So you should see, since we're trying to maximize, that the loss will go up. We had a maximum cutoff of 15, but it usually doesn't hit that. It looks like it got close on the third one here. And these are the different shapes. So we started off at this shape of an image and successfully got it a bit bigger and bigger. So anyway, so you should get something like this. So mostly what's happening is it's adding on kind of textures into different areas in here. But again, you can get big different effects by the layers you choose and the settings for the context for the layer and things like that. All right, so that was just a real quick example of a type of image generation, generative imaging technique. So, just to summarize a couple of the things that we looked at, I would strongly suggest that you explore that if you're interested in it. So, this is much simpler than the image generation stuff that you'll see out there, but these kind of same concepts are being used in various image generation systems, scaled up with much larger data sets and other techniques to do sequence-to-sequence learning so that you can start with textual input to generate images based on your textual input. But anyway, so this kind of image generation consists of running a convolutional network in reverse to generate inputs based on the representations learned by the network for different layers. So the results for this kind of stuff can be fun. You can get much more interesting things by playing around with what layers you use and things. So, and yeah, this kind of process isn't specific to image models. So you could also use this, like previously we looked at generating sequences. You could use this kind of thing to generate, like an optimization, a maximization technique to generate speech or music as well in a different way. You would get different results from that. Okay, so that's it for this video. So stick around for the next one. We'll look at another kind of generation technique for doing what's known as neural transfer